Good morning, Mr. McDowell.
Good morning.
Mr. McDowell, you in my Linux class?
Yes, sir.
Yeah. I didn't get to your assignment yet, but I've been looking at them. When I asked y'all to do the long listing of a file that of all the files that you just created, I thought y'all would add the flag, those either asterisks or the question mark delimiters on the file on the command, like ls minus l underscore O1 file underscore O7 question mark question mark question mark, something like that.
I actually wasn't able to do my homework for that
Oh
week, so
man,
I'm not able to help. I'm sorry, man.
then I gave y'all that tell that night.
Yeah. What's the ninth? No.
Yeah, last night. Well, was it no night? Remember we had class, and I said, "Well, I'm gonna open it so y'all, because I want my assignment. So turn it in by tonight."
Wait, which one are you talking about? Hold on.
In Linux, that last one where you had to do the cat
The file
concatenate.
management?
Right.
Yeah, no, that was due on the 30th, and I wasn't.
Right, the 30, which was the day we had class, right?
Mm-hmm. Yep.
Right.
I
But it,
procrastinated it, and then I just wasn't able to.
oh, okay, all right, man.
I'll be honest with you. I mean, I did. It is what it is. I procrastinated.
Yeah.
I usually try not to.
Right, because it wasn't that hard, but the commands, if you miss something, it could cause issues or whatever, and you could work your way through it to understand.
I usually, if I have a problem, I just look up my problem the best I
Yeah,
can.
right,
I know not everyone does that for some
right.
reason, but
But that's computer science, though. You understand?
oh yeah,
A
I
lot of
figured
times,
it's as good as your Google foo, you know?
correct. That's right. Because you won't know everything, but if you know how to manage and use resources, man, you'll come out kind of like a IT tech.
Mm-hmm.
IT tech gonna have a certain level of education. They're gonna know, a good deal about something. But ever so often, it might be that one thing that they never ran across. But if they know where to get it and how to interpret it to apply it, man,
Mm-hmm.
they great. You know what I'm saying? And
The
then
one
once
thing
uh,
when you're looking up stuff for C++, I hate it when when the people who are like helping the question, like they don't using namespace
right,
standard. So it's like just more cumbersome to read. You can still
right,
do it,
right.
but it's just like, come on.
Right, correct. Yeah, you're looking at those what scope resolutions with C out colon whatever, and you're like, man,
Yeah.
why this? What's going on here? What's all this extra code? But it's nothing. If you add that, like you said, it'll take out a whole lot of things. Yep. Yeah.
Makes me wonder, why was it like that in the first place?
Well, I think what happens is many times people write code, and C++ is a low-level language.
Mm-hmm.
So if the less that how would I say it? The less that you load, the harder it is for somebody to crack. If you understand what I'm saying,
Mm-hmm.
because they'd have to, if they trying to write code to interject in your program and you didn't do the standard library, and then they code have like C out whatever or C in whatever, then it won't work. You know what I'm saying? Or
Mm-hmm.
other libraries. So it's like if I want it, I'm gonna use it. If I want it, I'm gonna use it. So I guess a novice a hacker would have to kind of know that and whatever.
Mm-hmm.
And also it could be for resource purposes, because the more you load at the time, the larger your program is, rather
Right.
than just use it when you just need to use it. Right. So it just depends. Yeah. But like for us to learn it, like I say, putting that in, it solves a whole lot of issues, and it takes a whole lot of extra code
Yeah, it
out
seems
of the
like a whole
program.
lot of extra work, and it
Right,
just
right, right.
seems to me like why, like maybe okay, maybe back then it was different, but like nowadays, why would
Right.
you
Why
still
use
use
it?
that?
Right,
Yeah.
right, right. But you're gonna see when we get to what we're gonna get to, even with files, when we get to where we can actually take create a file object. Don't give it an actual IF stream or OF stream. We'll just give it F stream. Then later on, you'll see how you can use scope resolutions to change it to be an input file, output file, append the file, or whatever, saving binary or whatever. So you'll
Mhm.
see how those scope resolutions come into play. Also, when we start doing classes, you'll see scope resolutions when you're gonna have variables and whatever that's a part of those classes. So you'll see it again. I mean, whenever you saw that code with that dot dot, you'll see that again
Mhm.
later on in the chapters.
Okay.
Right, you'll see it, and you'll somewhat understand. Oh, okay, they're using it here. Right. Yep. Yeah, looks like we got 4 people in the class. Cassidy Purnell, they emailed me. What you had emailed me for? Oh, the assignment, right? Oh, they don't have their mic on.
Yeah, the assignments, they said they was due at 11 a.m. instead of.
Right, and I changed it to yeah, because I normally make it PM, but and I said, okay, I'll just change it. Yeah. And normally when I change it, y'all do get an email, right? Saying that the assignment has been updated or whatever. Correct?
I'm not sure.
Oh, okay. All right. Mr. Robinson coming on there. What's up, Mr. Robinson?
What's good?
All right. Mr. St. Cyr, how you doing? You got his mic on.
Pretty decent.
All right.
I didn't see a notification when you did it, so I didn't submit the docs still.
Why?
I didn't see a notification saying that you opened it back up until 11:59.
But when you email me and I say I'll go ahead and do it now. Then I email and say, and normally I don't do that. I say done. All right. Hello.
Huh?
Then I responded and said done once I did it.
I'm opening the app right now. I didn't see it.
You didn't see it.
No.
It doesn't.
The app should
Oh, it
be-
doesn't. Oh, okay. How many people had issues with the program?
I mean, I did it last week, so I didn't have to worry about it.
Oh yeah. Remember you said that.
Hmm.
Yeah. Like I say, you have to put in a little time. Yeah. Yeah. And like I say, those who had the columns, all you had to do was invert the row and column, but then also change your division statement at the outside of that inner loop, so that you can divide once you get the total. When you're calculating your averages. All right. So any questions? Any questions? Question about the test or whatnot? Everybody took the test, took the quizzes.
Yes, sir.
All right. Okay. So let's look at. Let me go into my share. Let's look at the next chapter. Now, the next chapter, same thing, class. The next chapter dealing with searching and sorting. All right. So we understand when we search for something, we actually looking for a particular thing. All right. Looking for a particular number, looking for a particular person, looking for whatever, but we looking for something. When we sorting, we actually arranging things in a particular order, whether it's high, low, A to Z, whatever, or in reverse. 10 like from low to high. I said low to high. Should have said low to high first. Low to high, or either from Z to A. Now, so in computer science, there's many different search algorithms, all right, and even sort algorithms. But we're going to talk about two, and we're going to program with two search algorithms and two sort algorithms, all right? So a search algorithm is a method of locating a specific item in a larger collection of data. So if you have a large collection of data, to search it, there's algorithms to search that data, all right? It is very common for programs not only to store and process data stored in arrays, but to search arrays for specific items, right? So like I say, just reading in the data, okay, oh, well, I have it. So now I could write code. And if you understand, when you go to maybe financial aid or whatnot, the first thing they ask you, okay, what's your L number? So you give them your L number, and then what happens, they put it in, and then the code does what? Search through all of the students' records to find your L number, and then everything that's associated with your record. Okay, so even with businesses, like when you go to the bank, you go to do something, you have to have your account number. Then they'll pull up your account number if you're depositing, whatever, if you're withdrawing, whatever it is. If it's a loan, it has to be associated with that number. So, but let's have to search it, and then once they search it, they have your name, your address, and whatever else about your account that they need. All right. So almost every computer type program that's dealing in the world, have some type of search algorithm, especially if you're inputting something, all right, to find something. All right, now we will discuss two search algorithms. One is a linear search, and then the second is a binary. Now, linear search is pretty much self-explanatory. What happens is you're gonna have a value you're searching for, and then you check each individual item in that array that you're looking, against that value that you're looking for. So you're gonna check it with the first one, check it with the second one, check it with until you find it. Once you find it, okay, it's found. All right, that's a linear search. A binary search, what it does, it takes a collection of data and splits it in half, and at that halfway point has to decide whether the value you're looking for is lower or higher than the middle value that is found. And if it's higher, then it just uses the last half. If it's lower, it uses the beginning half. And then what happens is it divides it again and check, depending on if it's high or low, it checks again. Divides it again, see if that's the value. If not, then it checks the lower half or the higher half, and then it eliminates that. So your data is being reduced by half, then by quarter. By quarter, then by eight, and on and on and on and on. A fourth and a quarter. Well, a fourth is a quarter and eight. So what happens is the linear search is a more inefficient way of searching for something if you have a large database, as opposed to the binary is more efficient if you have a large database. But if you really a search range. But if you have just a small number of items to search, hey, linear search will work, because it's so, it's good with smaller amounts of data. So the linear search, okay, it's a very simple algorithm, sometimes called a sequential search, because it's going to go from one to the next and step up to the next, to the next, to the next. It's almost like when you, and many of you may not know, when you had a cassette tape player, and you had, you bought a cassette tape and you put it on side one, and it's at the beginning. but the song you wanted to listen to was song 5. You had to what? Sequentially go through fast forward through each one of the songs to get to the song that you wanted. That's going through it sequentially. You have to go through each one to get to the next one. But we know now a lot of things is done randomly, like on the CD, where you can choose and skip and randomly choose a song that you want to choose, which makes it much faster and easier. All right. So the linear search, it uses a loop to sequentially step through an array. And we're talking about array because our assignment is going to be dealing with an array. All right. Or it could be a vector, on and on, whatever, as long as there's a list of numbers. All right. It starts the search with the first element. All right. And then it goes on through. So if I had an array of 2 million elements, and the value that I'm looking for is not in that list, I would have to check all 2 million elements to see, and then say, oh, it's not there. And depending on how fast my process is, all I'm doing is wasting my time. All right. So to search in a larger list of data, a linear search is kind of a disadvantage. All right. The search process it compares, as I said, each element with the value being searched for. All right. So if I have like the number 5 and I have an array of numbers, all right, it says, okay, it's 5 equals to the first element, okay, which is if it's number sub 0. Oh no, then increment, is it equal to number sub 1? Nope. Is it equal to number sub 2? Nope. Is it equal to number sub 3? So on and on and on and on until it finds it. Once it finds it, and then it will say, okay, it's found, and what element is found, and then you can output it. All right. Now, so it says it compares each element with the value being searched for and stops when either the value is found or what the end of the array is counted. Because what, you can't continue on searching, and you don't pass the boundary of your array size, because now you're searching in an area on your computer that's not a part of your array. All right. If the value being searched is not found in the array, the algorithm will successfully search to the end of the array. So that means, like I said, if you got 2 million elements, it will search every last one of them just to tell you what is not found. All right. So depending, that could take up time. Now, class, this is the pseudocode. Okay. This is the pseudocode that tells you how that linear search works. Now, I'll say this, in computer science, many times you are given, or you can find pseudocode about how to program a certain thing. Sometimes you are even given the actual code, all right? This is the actual code, all right? But in doing so, when you get either this or this, you have to know how to interpret this, if it's pseudocode, and then write it in what? The C++ language. If you get the C++ code, you're gonna have to take this code and modify it to match the variables and whatnot that you have within your program. You can't just say, okay, they say this is the code, I'm gonna copy it and put it in and it should work. No, you have to modify what they're passing int array, int value, and another int value. But if you had your search list, you was passing 2 different int arrays, this would automatically give you errors, because your function header would probably be different than what you're working with. All right. Index, you'd have to know what index is, because what, you may have to change it, but then it says what, it's used as a subscript. All right. So it's used as a subscript for the array. So we know that normally when we create a loop and we using a subscript, that subscript won't be changed. That's what we're going to use. Like for int x equals 0, x less than 10, x plus plus. 10 is our index subscript, all right? Or what? 10 x is our subscript. So we know that x gonna go from 0 to when it get 10, it kicks out. So x will be used to do like list sub 0, list sub 1. So we know we should see x anytime we referencing our array. But then int position equals 0. You say, okay, well, why is that there? All right. That's there because for the simple fact, if you notice this header file, it says int now. We don't have void. So what's happening with this algorithm is searching the list to see if it finds the value. If the value is not found, we don't assign -1 to position. So what? -1 is outside any position of the array, right? Of any array, because the array position starts at 0 and goes to positive infinity. So if -1 is set to position set to -1, and we go through this algorithm never finding our value, then what we're going to return back to the main calling function. I say the main could be another function, but in our program, the calling function is the main. We're going to return position, which is what? -1, which is of what data type? Int. Okay? So that's why this variable is introduced. But then look here, we have a Boolean value, a variable called found. We setting found to false. Now remember, false, true, 0, 1, right? So we setting it to false. So if we don't find the value, found will stay equivalent to false. And it will allow us, see here, if not found, that means if it's false. So while index is less than the number of elements, meaning the size of the array, we're going to check sub 0, sub 1, and not found. So as long as we go through the array and it's within the range of the array elements, and it's not, and the value not found, we're going to keep going through the loop, keep going through the loop, keep going through the loop. But once we find the value, look, found equal true. And what happens is when it gets back up here, found equal true, all of a sudden, index position become the value of the index. And then when we get here, we kick out because found is equal to true. We might not be to the end of the elements, but found is equal to true. And well, this and this, both sides has to be true. Remember we talked about that when we talked about and or last semester. Both sides has to be true. And if this is true, we're still in the range of the elements, but this is false, it kicks out. And then what? Returns the value of position of the array element, and then we can print out our data. So let's go through this loop. So while index is less than number of elements, index starts at 0, okay? And num element not found. Found is set to false. So that forces us to fall into that loop the first time, at least one time, because if the value is in the first position, bam, it is found. Oh, we out of it, right? So as long as it's not, we're within the less than the number of elements and it's not found, if list sub index, which means what? List sub 0 is equal to the value we're looking for. And then if list sub 1 is equal to the value we're looking for, list sub 2, on and on. It's going, as the loop goes, it'll keep checking for that value. So if any one of the elements in our array, which is list at this point, and see, that's another thing, your array name might be something else. But if list sub index is equal to the value we're looking for, what we do, we set found to equal true. We set, and then we set that index value to equal to position, and then we kick out this loop. It's going to increment index, but it won't cause any problem because we're not dealing with the loop anymore. We done kicked out, and then we're going to return position back to the main function where we can reference our arrays our different arrays, like say our name array sub whatever that position is, our what it is, year array, whatever that position is, and our amount our amount array, whatever that position is, and you can print out that information. All right. So this is the actual code. But as I said, you have to know what it is the variables that your program is using. And like I say, most of them index you might not want to change because it's already in here. Position you might not want to change. Boolean found you might not want to change. But depending on the array name and maybe the array type, right? Because you might be using looking for a value that's of double. You know, you can't just say int whatever. Now, so this is the size of the element that they pass in, which is the size declarator. And this is the value that was typed in, like in the main that said, please enter the value to search for, or could be please enter your ID number, whatever it may be. You know, that'll be passed, and then this the elements of the array, and this the actual array. All right. Okay. So this is somewhat telling you how the advantages and disadvantages of a linear search. Advantages, it's a simple code, but it is inefficient in that the number of times that you have to process it can be, can increase depending on if it's not found and if the size of the array is large. All right? It's easy to understand. Okay, that's an advantage, and there's no special requirements on stored data. Now, that's a key point. But when we get to our I think it's our what search that is, our sort, our linear sort. I mean, not linear, selection sort. Not the selection. No, our bubble sort. When we get to our bubble sort. No, as our selection sort, one of the requirements is the data must be, no, not our sort, our, I'm getting confused. Our binary search, our data must be sorted in order for our binary search to work, okay? So even though we're going over the linear search, which actually checks each individual element. If you have a large array, large size array that you're checking, it can take time. And then you say, well, my program is taking too long. I'll use the binary search algorithm. But if you use the binary search algorithm, like I said, the one stipulation on the data is it must be sorted first before you can do the binary search. All right, so let's finish this and then I'll show you why we have to have it sorted in order to do the binary search. All right, so this saying, and this just kind of give you a little kind of statistics on how in searching through a linear search or using a linear search, how it could take a lot of time. All right, so if an array being searched contains 20,000 elements, and the value of the value is in the last element, the algorithm has to search through the first one all the way to the last one to say, oh, I found it. Okay, so that's one thing. All right, so it will search the entire array, which means it will process 25 times. I mean 2,000 times, 20,000 times. So on average, though. And that's just average, like flipping a coin. On average, you're going to have the same amount of heads as tail on average. Or every time you flip it, you got a chance for head or tail on average. All right, so they're saying on average, an item is just as likely to be found at the beginning of an array as near the end. So if you're trying to use that analogy, typically, for arrays with n numbers, whatever size it is, the linear search will locate an item in n slash divided by 2 attempts. So if I have an array of 2,000, on average, it might find it taking 10,000 loop processes on average. Depending on what type of the different. If you're looking in different arrays. Now, if you're looking in the same array, it's gonna be the same thing over and over and over again. But we talking about it looking at one array of size 20,000, another different one of 20,000. So on average, you may find one at the end, one at the beginning, one in the middle, one at the end. So on average, n divided by 2. So if an array has 50,000 elements, the linear search will make a comparison with, on average, 25,000 elements of what items of 25,000 items of them in a typical case. All right. So this assumes, of course, that the what element is in the array. All right, that is found. But if it's not found, we going through the whole array just to say what? Not found. All right. So if not found in the array, you will be searching each element from start to finish. So it just tells you n divided by 2 is the average number of comparisons, where n is the maximum number of comparisons. All right. So that's the linear search. All right. So let's look at the binary search. Now, like I said, the binary search takes the data and divides it in half. All right. That middle number is checked to see if the value is higher or lower. So if we're doing that to determine which side to check, if we're doing that, our data must first be what? Has to be what? Sorted, right? So we sorted from low to high. So now I have my number in sequence. So when I divide it in half, I'll check to see the value. The value of that number. If it is, I found the element. If it's not, then I need to say, well, is it higher? Check the high side. If it's lower, check the lower half. You understand? So that's why your data have to be sorted. All right. And then what it keep doing, it keep breaking it down, because if it's the lower half, if the number is less than the number the middle number that we checked to be searched for, then we take that and divide that in half, and then decide whether the number is higher or lower, and then have to determine which side we check again. All right. So the binary search is a clever algorithm that is much more efficient than the linear search. It only requires that the values of the array be sorted in order, right? That's the first thing you have to do. You have to sort the data in order before you can do the search. Instead of testing the array's first element, this algorithm starts with the element in the middle. If that element happens to contain the desired value, well, it's all over. You found the value. All right. Otherwise, the value of the middle element is either greater than the value that we're looking for, or less than the value that we're looking for. If it's greater than, okay, and in the list, the value will be found somewhere in the last half of the array. Okay. If less than, again, and in the list, the value will be found somewhere in the first half of the array. All right. In either case, half of the array has been eliminated. So however large your array is, when you chop it in, if it's sorted, you chop it in half and say, oh, the value is in the high side, then the only thing you're working with now is the high side. All right. And then on and on, you keep cutting it in half. So let's look at this. All right. And this is an example. I'm going to move this down here. So if the desired, I can't move this. If the desired value is not found in the middle element, the procedure is repeated for the half of the array that potentially contains the value. Okay. And let's look at this down here. So for instance, if the last half of the array is to be searched, which means the number was greater, All right, the algorithm immediately tests its middle element. If the desired value isn't found there, the search is narrowed to the quarter of the array that resides before or after that element. All right, this procedure continues the value search until found or there is no elements to test. So if you look at this example, all right, it's searching for the number 38 using the binary search. So here's a list of numbers. But first, these numbers has to be what? Have to be sorted, right? Remember, you have to, and look, this is whatever name of this array, sub 0, sub 1, sub 2, all the way to sub 17. So this array size is 17. So, but what's the values of the array elements? 10, 18, 22, 38. So see how your numbers are increasing. So the values, this int array has 18 elements, and the values are 10, 18, 22, 38, on and on, all the way to 95. Those are the values. So what happens? The array is divided in half. So now, is the value of 83 greater than or equal to the half? Okay, is it on the 6? If it's greater than equal to the 60, okay. If it is, it's using this half. If it's less than, it's using this half. All right, but it's greater than the 60. So now we use this half. All right, so we take this and we go here. We divide it. Is it greater than equal to the 80? It's greater than. So now we use this half. All right. So now we divide it again. Is it greater than equal to 83? Oh, this is our number. All right. So see how it took what? 1, 2, 3, 4 processes. And if I'm saying like 1, there was the first cut. There's the second cut, third cut, and then we found it. All right. Whereas if we was going to do a linear search, we'd have to check, 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 on and on and on and on and on and on. Oh, here's 83. So we would have to go through this 15 times to get to this, whereas the binary search took 4 tries. All right. So that's the difference in the two algorithms. Okay. All right. And remember, in order to do this algorithm, you have to have the data sorted. But in your programs, regardless when you're doing the linear search or the binary search, we're going to use the 2 different algorithms. All right. So to sort the data. Now, here is your binary search pseudocode. All right. This is English-like language as to what is to be done in order to search for data using the binary an algorithm. All right. Now, this here, if I can increase it a little bit, let's see something. This is the actual code for. I'm trying to come up a little bit. This is the code for a binary search. But again, as I tell you, when you look at this code, all right, you cannot say, okay, well, the book gave, or, well, I looked at it and they said, this is what I needed to use, or this is a binary search, all right? No, you have to take the code. The code is actually written, all right, but you have to take it and modify it to fit what you're doing, the type arrays you're using, the variables you're passing, and then modify what array you are doing a search on. All right, it's almost like if what I say you're working on anything that deal with wires. All right, many times you might have a case where you bought the piece, or let's say a part for, it could be a part for a car, it could be a light fixture or something, and the part you bought has more wires than the part that comes off the whatever equipment. You have to what? Know how to manage to say, okay, these two wires go together to go to this wire or whatever, or this wire is not needed or whatever, so that you can make it what? Work for that situation. And the same thing here, and it's not that that part won't work, you know, it's just that the wiring scheme was different. And like I say, the same thing here, you know, you got to be able to fit your code to what you are doing so that it'll work within your program. All right. So let's look at this code. All right. So what it's doing, it's passing the int array from the main program. Your int array is going to be what in your program? Well, I never posted it yet, but it's going to be year. Okay. Year going to be your int array. All right. Then you're going to pass the int, the size declarator. All right. That size declarator, how many elements in our array? 10, I think. If I'm not mistaken, I think it's 10. And then here, this would be the value that you prompted the user to input in before you called this this binary search. All right. So now, here we got a variable, int first equals 0. Oh, well, it's just being introduced. So first is a part of that algorithm. It wasn't anything passed or anything. It is a variable that they're using in this logic. So if you try to change first here, you're going to have to change it everywhere in this logic. You understand what I'm saying? But if you leave it as is, you don't have to, well, you have to worry about finding it and changing it somewhere in here. Last, we know the algorithm, what it does, you have the first and the last, and then you split it up. And then when you split it, then you're going to have a new first and last or first and last, depending on what side you use. So those two are being introduced. But last is given the value of what? The size of the array minus 1. All right. So it can't go to the last one and go to the size minus 1. Then you got a variable that's introduced called middle. That's going to be the middle point of whatever side you choose and have to keep dividing, all right, when you divide it. Then here we go, position equal -1. So if we never find that value, position will be -1, and we're going to return what? -1 back to the main function, all right? Then we have our Boolean found, our variable found again, all right, which is equal to false, because we want to go through the list at least one time to check to see if our value is found. All right. Now, again, pretty much the same style of while loop. All right. All it did was kind of reversed it, but still both sides has to be true. While not found, which means it's equal to false, that's true. And first is less than last. Now, what that means? Remember, every time we checking our loop, we what? We decreasing the size, and it's going to eventually cut in half, and first going to equal to what? Last. So that's why it has this in there, and first is less than last. Now, here we go. Middle. So what happening before you even start processing the loop? You know the size, right? Because the size, what they did here. They set first equal 0. They set last equal what? The size of the array minus 1. So what? Middle is equal to first plus last divided by 2. All right? So that's 0, the first time, 0 plus the 18, whatever, in our example, divided by 2. So if that middle value, all right, array submiddle, because the middle here represents the middle, the subscript of that middle value of the entire array, because this is the first time through. If that array submiddle index, all right, is equal to the value we're looking for, if it is, we finish with our search. And it's the same algorithm somewhat as in the linear search. We setting found to equal true, but here we setting position to equal middle. Not index. Well, we didn't use index here. We use in middle. So we set position equal to middle, all right? So this is not executed, class. All of this is not executed. This else is not executed. This else is not executed. It kicks out and it does what? Return position, right? But if it's not found, all of a sudden, then you have to make a decision. Is the middle greater than the value that you're looking for? If it is, all of a sudden, now last equal middle minus 1, all right? So, and then otherwise, first is equal to middle minus 1. So what happens is you're trying to move the middle position. If the value is in the higher part, you're saying, okay, my middle value gonna equal to the end, okay? And my first value gonna equal to middle. So now I'm gonna check that higher part. So see, I done changed my subscript area. So when I'm checking from the middle to the high, to the last part of the array. And then each time you check, it's gonna keep reducing middle and last until you get to nothing to check for. So it's gonna keep on going through this part. If it's not found, cutting it in half, cutting it in half, cutting it in half, till it's actually checking the same element, and then it kicks out. And if it never finds it, and middle is equal to middle, and then first is less than equal to last, or well, not saying that, yeah, then it kicks on out. All right, it kicks on out. All right. Or is not, and found is equal to true. Well, true gonna kick there or not on that one. But if it's first is less than or equal to last, as long as that happens, it's gonna stay here and do this loop. When that's not, and it's not, and it's not found, then it kicks out, and then whatever position is, if it's -1, it returns the -1. So that's the algorithm. All right. Now. And that's the search, right? So the search algorithm, cool. Now what you can do, you can write some code, create a little array, and then write a type of value and see how it works. And then you say, okay, I'll set this array up, this code up to match what I'm going to use in my program. And then all you can do is copy and paste that section into your program. But like I say, at least this is the actual code, but you have to match it to yours. Now, some details about the binary search. The binary search obviously is much more efficient than the linear search, right? Every time it makes a comparison and fails, all right, to find the desired item, it eliminates half of the remaining portion of the array that must be searched, all right? So to search an array of 1,000 elements, okay, would take no more than 10 comparisons, because you keep cutting it in half, all right? Compared to a linear search algorithm, which would make on average, now remember we said on average because it could be found at the beginning or it could be found at the end, on average of 500 times, all right? So they give you this little scenario where the power of 2, all right, are used to calculate the maximum number of comparisons for binary search, for the binary search, okay, will take on an array of any size, all right? So it just tells you, give you a kind of average of that too. The power of 2 is somewhat what on average what it'll take. Simply find the smallest power of 2 that is greater than or equal to the number of elements in an array. So it's just telling you a maximum of 16 comparisons will be made on an array of 50,000 elements, which is 2 to the what? 16, which is equal to 65,536, okay? And a maximum of 20 comparisons will be made on an array of 1,000,000 elements, okay? That's 2 to the 20th, which is a little over 1,000,000. You understand? So see how they got it, how whatever 2 to whatever is equal to, close, that's what they use as to an average of how many times it will do to search the entire array to find what is needed. all right, which is considerably less than having. I'm gonna do a linear search and I'm checking 25 elements. You do a binary search, and no matter how large it is, a million elements, and you do less than 20. 20 or less each time. That's the efficiency of doing the binary search. All right. So, any questions about the search algorithm? Search algorithm search for a particular value. All right. So, and if we look at this code, well, this is just the function. Okay. If you look at this, okay, introduction to sorting algorithms. Okay. Sorting algorithms are used to arrange data in order. Oftentimes, the data in the array must be sorted in some order. So we know that what? If we're going to do a binary search, our data must first be what? Sorted. In some kind of way, it has to be sorted. Now, if you're doing a linear search, you don't have to sort. But in your program, I do want you to sort, okay? And that's all. I just want you to get practice in doing the linear search and the binary search and the bubble sort and the selection sort. All right. So you can sort alphabetically or grouped, or you can, if it's int data, you can do high to low, or you can do low to high, however you choose. All right. To sort data in an array, programmers must use an appropriate algorithm, sorting algorithm. And there's many different algorithms out there, okay? A sorting algorithm is a technique for scanning through an array and arranging its content in some specific order, okay? And the two simple sorting algorithms are bubble and selection sorts, all right? Now, before we get to the sorts, all right, you're going to be writing your program, all right, and not so much the search, but the sorting. When you're going to be sorting your data, you're going to be sorting your data and arranging your elements, correct? But you cannot just sort your data and arrange the elements of just that one array. If I have 20 different arrays with 10 elements, the whatever array, like say if years of two data should match with array 1 sub 2, array 10 sub 2, array 5 sub 2. So if I'm gonna move array year sub 2 to the 0 position, all right, or element, I have to move array 1 sub 2 to the 0 element. I have to move array 5 sub 2 to the 0 element. So the thing is, in this sorting, I gave you 3 arrays. So what you do to one array when you're sorting, in a sense moving, you're going to have to do to all of the other arrays in order for the data to stay aligned. Now, let me give you an example of I bet you I can't get into it because I saw I had an error. It's going to try to, what's going on? Okay, so now, how many people have used Microsoft Excel? All right, so if I type some names here, if I type Bill, and I'll type 2010, all right, and I'll type, all right, I'll type these values here. I'll just make this, and I'll increase this. All right. Okay. Just want to bring it up a little bit. All right. So I'll put Bill. I'll put Fran. Let's see. Say 1844. Just put some numbers in there. I'll say, and Johnny, John, I'll say 1946. All right, and then I'll put this. All right, so now I have these names here. In Excel, if I highlight this, and then I'll say sorted, all right, I'm gonna get a warning, all right? I'll sort it from smallest to high. I'm gonna get a warning, and this warning tells me that I'm about to sort only these years here. I could have put a title, but only these years here, but I have data to the left and to the right that if I'm truly doing a sort, I should select all of them and then ask me if I want to continue or just go ahead and expand it. Watch what happens if I just continue with the current selection. Now, Bill, what's his year? Bill's year is 2010, all right? But if I do the sort here, watch what happens to all the year value. Well, let me do this first. Let me cancel this. What I'm gonna do, I'm gonna copy this and I'm gonna paste it to the side. I'm gonna copy it. I'm gonna paste it to the side here so we can see. All right. So now, what I'm gonna do, I'm gonna select this and I'm gonna do a sort. All right. And I'm gonna get that same message. All right, but I'm gonna continue and sort. Look what happens. All right. What was Bill's year? 2010. But what is it now? 1845. You know, that was supposed to be Betty's. What was Fran's? Okay, Fran's was 1999. But that's Thomas. Because what did I do? I only sorted what? This data. And once you do that to your data, you just took it and scrambled it up. Now, sometimes that's good when and I forgot what it's called. A lot of times when people have databases that they want to share with other people, but they want to keep people names anonymous, or maybe their financial information anonymous from the person that it is. I think it's aggregate. They'll take the data and they'll swap out they'll mix up the names so the names won't actually match the person, and so you're not tying in the data with that person. All right, but this is not what we want to do. We want to make sure when we call up Bill year is 2010, but then also his amount here is $183.23. So you see how if you write that code using the sort algorithm, that sort algorithm just works on swapping one of the columns. You have to, wherever you're moving the data for Bill, Bill was 2010. So when you move 2010 here, you should have moved Bill down here. When you move 1845 to the first one, you should have moved Betty up here. You understand? And the same thing goes for the amount. When you move Bill down here and 2010 down here, you should have moved $183.23 down here. All right. So, and let me show you what the data should have looked like when you finish sorting it. So what happens is we're going to select this, and now we'll do the sort. It might ask me the same thing because I got other data on the side, but I'm not worried about it. Look, so look what happened. Now, no, I did it wrong because I did it by the wrong person. Okay, I'm going to do it this way. All right, and then I'll do the sort, and I'll expand it. Yep. All right. So now, look what happened. It's doing the sort on the year, but then what? All of a sudden now, Betty moved up, right? And Bill moved down, and everybody else is in the proper order along with their amounts. And this is sorted based on that year. Because what? You still have Bill 2010, $183.28. You understand? You still have Betty 1845, $202.38. But then yet what you have 1845, 1846, 1985, 1999, 2010 sorted in ascending order. Okay, so I wanted to show you that because when you're writing your algorithm and you're doing your checks to see if your algorithm or your program is outputting correctly, you want to be able to do that check to see if you're moving that data, like you're supposed to. So let's look at the bubble sort. So what happens with the bubble sort? In short, the bubble sort runs through the code. Runs through the elements of the array, checking to see if the first value is greater than the second value. Then it moves up, acts it again, moves up, acts it again. If it finds that the first value is greater than the second value, it does a swap. Now, the thing is, as long as you in that loop and you do a swap, you're gonna keep going through the loop. You go through the loop until there is no swapping done. All right. Give an example of this process. You can read through this, but what happens is it compares element 0 with element 1. Is 7 greater than 2? Yes, it is. So now it swaps. Now 7 is in the one element position, and everything is moved up. Now I'm comparing element 1 with element 2. Is 7 greater than 3? Yes, it is. So it does the swap. Then it bumps up. Element 2 compared to element 3. Is 7 greater than 8? No, it's not. So it bumps up. Is 8 greater than 9? No, it's not. So it bumps up. Is 9 greater than 10? 10. It's greater than 1. Yes, it is. So it swaps. And then what? I'm at the end. So now I'll go back to the beginning of the loop and check to see if I did any swapping. Oh, yes, I did a whole lot of swapping. So swap was turned on. So now with 2 at the beginning, I ask if 2 is greater than 3. No, it's not. And 7 been moved. Is 3 greater than 8? No, it's not. All right. And then here, I think, well, no, it wouldn't be 8, it'll be 7. 3 greater than 7? No, it's not. Is 7 greater than 8? No, it's not. But then is 8 greater than 1? Because remember, 9 was put at the end. If 8 is greater than 1, yes, it is. So it's going to swap 8 and 1. So see how many times it's going to take just to get the 1 to the beginning? You know what I'm saying? So it's going to take 1, 2, 3, 4, 5, at least 5 times to go through that loop to get the 1 in the first position. And mind you, you're doing all these other swaps in singly too, but this 1 is all the way over here. So at least it's going to take 5 times to get that 1 here, 1 time through, here, 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 and here. All right. So that's how the bubble sort works. All right. That's how the bubble sort works. All right. So, and it's going over the same thing that we went through, remember? And so it moved the 9, the 1 and the 9. But then that next time through, which we just did, it does the 2 doesn't change, and 3 and 7 doesn't change, but the 7 and 8 doesn't change, but then the 8 and 1, it swaps. So the 1 has moved here, and then on to get that 1 there. And once it's done, then you successfully what? Completed your sort, and there's no swaps, and it kicks out. All right. Here is the bubble sort algorithm. Okay, this is the algorithm. So if you say, man, I don't know how it works, go through this, look at it, and see. This is a program, all right, with the bubble sort in it. Okay, so where's the sort? Look right here, sort array. From here, it starts here, and it ends here. Okay, so the array algorithm starts here, and it ends here. So let's see if I can increase it a little bit so you can see. I want you to see the whole thing. I can't do it. Okay. All right. So let's look at it. So first of all, they're passing what? An int array and the size of the array. Now, let me ask you this question. Remember, we just looked at an Excel worksheet where we sorted the data by the year. So if I'm sorting by the integer array here, I'm only passing an int array. What must I do here for my program? Remember, we talked. If I'm swapping information for the int array, I must do the same thing for what? For all other arrays that I have. So not only should I be passing my int array, I should be passing my string array, and I should be passing my double array. Everybody understand? Everybody on point here? Because when I'm doing my sorting, all right, and putting them, arranging them in order, I have to keep everything together. It's almost like if the teacher say, "Okay, get in line," everybody get in line. Then the teacher says, "Okay, now put yourself in order based on your last name." But you have your book bag in line with you, and you put your book bag down, but you move. So you done moved in alphabetical order, but your book bag may be by somebody that the book bag does not belong to. You understand? So you got to be able to swap what? Everything, so that everything can be related. All right. Everybody kind of get that picture. All right. So you have to swap the name array, which is the string, and the amount array, which is the double, when you're doing the swap here. And if you notice here, you see the word swap down here. So, but there's some things you have to do. So let's just look at the swap for this single array. So what they did, they set a Boolean value to be swap, all right, to be called swap. But they got an integer variable called temp. Temp will be the value that I'm going to store my temporary value so I can manipulate my swap. Okay. Now, how would I ask this question? Mr. McDowell, you still there?
Yes, sir.
All right. And who else? Let me see who else is there. Mr. McDowell. Miss Frierson, you there? She might be at work or something. Say Mr. Edwards, Mr. Williams. Mr. Williams. Here. Mr. Robinson. Mr. Robinson? Are y'all participating, or y'all just allow me to record and then y'all just watch the record? Mr. Parnell. Hello? Mr. St. Cyr. Wow. All right. So, Mr. McDowell,
Yes, sir.
if you and I had to swap pens, okay? So you had a red pen and I had a blue pen. And I would say, let's swap pens without ever having two pens in our possession at one time. Okay? Kind of get it in your mind. We're going to swap pens, right? You have a blue, you have a red, I have a blue. How can we swap pens? I'll get the blue, I'll get the red, you get the blue, without us ever having two pens in our possession at one time?
You would do it exactly at the same time, I would assume. It would
No.
be like a trade-off.
No.
No?
No.
You would have to have a third party then, I assume.
There you go. And that's what that temp var. And see, I'm trying to get you to think. You know what I'm saying? Because that's what coding is. So if we have that third person, then what we can do?
Hand it off to them.
Go ahead.
They would have two at the same time, but I assume
No, they won't. Not if you do it in circle.
Oh, in a circle, right.
Right. You got what I'm saying?
Mm-hmm.
So you can hand yours to them. They the temp person. I hand mine to you, and they hand yours to me. Right?
Yes, sir.
And that's what that temp value is. And if you look down here, that's what it's doing. Look, temp is equal to ARR sub count. The first time through count is 0. So say that's your red pen. You giving it to the temp. But then ARR count plus 1 is put into ARR sub count. So now the blue, you getting the blue pen. You got me?
Yes, sir.
And then me, temp is being given to ARR count plus 1. So here now I get the red pen from the temp. So that's how the swap works. All right.
Mm-hmm.
So you create that variable, and then you put that value in it. Then now you can overwrite that value and then come back and add it to add a new value to that variable. So that's how it works. And once you understand that concept, it's like, oh, okay. But now that's only for the what? For the int array, right?
Mm-hmm.
So if we have an int temp value, we need to have what in our program? We got 2 other arrays, a string temp, right?
Mm-hmm.
And a float temp or a double temp, because we got to, as we do for one, we have to do for them all so that all the data can be what? Steadily aligned. So what happens here, it tells us to do, because what? No matter if our array is already sorted, we want to check it first, right? We can't take for granted that it's sorted, right? So let's just do the algorithm. So swap is equal to false. We don't know if we never entered the check to see anything. So we set swap to equal false. For count is equal to 0, count less than size minus 1. So, and why would you go to size minus 1 rather than all the way to the end of the array? Remember,
because we would assume that it starts at element 1, but it doesn't. It starts at element 0. So you would have to subtract 1 to make sure it's the same number of elements. Like, well,
close.
Because it's in my head it makes sense.
Right. Because when we start the first 2, say we check the first 2, say we check element 0 and 1,
Mm-hmm.
right? We check element 1 and 2. We check element 2 and 3. We check element 3 and 4. We check element 4 and 5. We can't check element 5 with anything, right?
Yep.
So that's why we do the minus 1. Because if we go all the way up to the last one, then we're trying to check outside the boundary. So when we check this to this, we finish. You understand?
Mm-hmm.
Right. Because remember, when we check, we do the whatever plus 1. Where we're at? Right here. See here? We check sub-0, then array plus AR plus 1. So when we get to that next to the last element, we checking that plus 1 also. You see what I'm saying?
Mm-hmm.
So we automatically checking it. And if we keep going, we're going outside the boundary. So we check the 0 and 1, 1 and 2, 2 and 3, 3 and 4. And like I say, up until whatever the last 1 minus 1. All right. So now the thing is, if I check element 0, the content of array sub 0 to content array sub 1, all right, the contents of ARR 0 and ask if it's greater than the contents of ARR 1. If it is greater, what we're going to do, we're going to take that information, put it in a temp. Take this information, put in 1. Take this and put in not 1, 0. And take this information and put in ARR 1. And then we set and swap to be true. So we can come back and what? Do it all over again, right? Well, at this 4, we're doing it all over again. And we're doing this swap in here until what? Swap is false. Once we do everything and there's no swaps, then we're kicking out our array is sorted. Now, so, like I said, we're going to need what? A string temp. a string and whatever temp value, and a double, whatever temp value. But notice here, 1, 2, 3, 1, 2, 3. That's the swap for my integer array. So now what? If I have this to swap my integer array, and this is the time I'm swapping it, I need to in here have what? 1, 2, 3 for my string swap. So those same three type of statements. And then for my double array, same 3 types of statements, right? Everybody understand that? Because if I swap my int value, I gotta swap my string and I gotta swap my double. All right. And once that's done, everything should still be in line. And then you can print out your array. All right. So that's the algorithm here. All right. So it tells us inside the sort array function is a loop, and which we just saw. All right. A loop nested inside a do loop. All right. The for loop sequence. All right.
Excuse me, Mr. Sylvester.
Yes, ma'am.
The dual enrollment students have to leave because we're at school and we have lunch.
You don't have to go eat.
Yeah, we do.
No, I'm just. Oh man. All right. Okay. Now. Huh?
I know, Mr. Sylvester.
Hey. So I want y'all to continue to read on this. What I'm gonna do? I'm gonna post the assignments. I'm not gonna make them do, but I'm gonna post them. Oh man, how can I do this? How can I do this? How can I do this? Because I wanted to kind of show y'all a program that was similar. Man, let's see something. Let me see something. Which one of it is? I think it's this one.
They already left.
They left? Oh, wow. Okay,
They're
so
hungry.
ah man, yeah, that's high schoolers, I tell you.
Mm-hmm.
Let me see something. And I'll just, man, boy, I tell you, I don't know if this is the one I did. All right, yeah, this is the one. What does it say? I'll just let it go. All right. See here, and this is the one I went over with my other class. And what I'll do, I'll go over this with you with the next time we meet. So what I did, I wrote code. Now, I wrote the code similar to what you're going to be doing. Notice I got a string array, an int array, a double array. Now, but mine is item name, item quantity, item cost. So you're going to have to kind of grasp. I don't want to do it exactly like the program. You understand? Because I want you to be able to work on the program.
Right.
But you're going to get your items. So that means you're going to open a file, get your data from the file. Then you're going to put the original data. Then whatever sort you're using, you're going to sort the data. And then you're going to ask for a number to search for from your integer array. And then you're going to do a binary search to find, well, you're going to do both. You're going to do I did the binary search because it was the harder one, to find the data. And then if found, whatever. And then after that, print the data again. All right, and close. This is the get, simple get. Look how many lines it took to get the data.
Mm-hmm.
You know, read in the data into the array. Selection sort. If you look at this sort, it's several places I had to make changes. All right, is it the sort? Selection sort. Where is it? I pulled in the string, I pulled in the int, and I pulled in the double. Because if you're sorting, like I say, you have to manipulate every array that you have. Otherwise, it won't work. All right? So what did I do here? Oh, this is the one I showed them where it will not work. So that's the one I have running now. But this is the one, where's the sort? The other sort. I think I have the other sort in here. It's at the bottom. I commented it out. Look. This is the other sort. And in this sort, notice what I have. String, min string. Double, min amount. All right, we didn't go over this sort yet. All right. And then what happens is, where at? Here I added these two lines. if I'm gonna have assign start scan to min val, I have to assign start scan to min string and min amount, because I kind of keep moving them as I move the others. And then here I added these two lines because what? If I'm gonna check to see if the number is greater than whatever, and then set min value here, I gotta set my min value to num1. I mean to my string and my amount. And then down here is my swap. Here's where I'm actually swapping. Now, I may not have to do this here. I may only need to do the swap because the value from start, whatever, is all I need. But I just added these to show you if you ever take the int one out, you can still what? You still have the code to where you actually doing the other swapping. All right. So this is pretty much the code that you would need to where your swapping goes on. Whatever that start scan for that and moving that to that, because that's that value. Start scan should be the same value for each one, and they're doing a swap, and it should swap. So if I run this, I'll run it, and then we could go. I'll run this, and what I did, this is the one that doesn't work. All right, my sort doesn't work at least. So if I run this, if it can come up. All right, so if I run this, so this is my original data, all right? Item, motor, transmission, tires, seats, mirror, seat mirror. Quantity, this is the quantity. Cost, amount, this is the amount. Now, it says enter value. So I'll input 82, 82. Now, when I output that 82, it should say found or not found, and then I should get my sorted data. So 82, all right, 82, where's 82? 82 here. Now 82 is really what? Tires, right? Right?
Yep.
So see what happened? It swapped the number, right? But it didn't match it. Because what? I did my swap, then I did my sort before I did my search. Right? So look, 82, cruise, and whatever, right? So I'm thinking it's right, but it's not, because if I look at my original data, 82 is tires, right? So now, so see how your data can come out wrong. You say, oh man, I got my data, it looked pretty, whatever. Nope, but check it, because it could be wrong. So if I take this off, all right, and I'll do this because I just, I put the data in there so I could copy it. All right, so if I do that, and then I take this off, and all right, so now when I run it this time, okay, I'm gonna open it up again. All right, so now I'll put 82. All right, see here, tires, 82, 111, well, yeah, whatever. So see here, so you see how, in the first one, I only sorted the quantity, which was my int array. The second one, I added those lines where I can change everything as like every array when I change that one array. So see how the data, both of them gave me output, but what? The first one was wrong, but this one it did it correctly. And then look, you got what? Matt's 19. Where's that? Matt's 19. So see how you can go back and check it? Knob 32. Knob 32. So yeah, so now it's correct. You see what I'm saying? So I'm gonna open up those programs. You can kind of get started, because I would say go ahead on and get started, understand what it is you should do, and read in the data, read in the data and do your output. So at least you got that part. Then you could kind of fiddle with the search part. I mean, not the search, the sort part, and try to print it out, see what it looked like, and say, oh, okay, I'm getting it, I got it, whatever. Because once you get the sort part, that's going to be pretty much one of the harder parts, the sort, I think. Yeah, the sorting. And once you get that, then you do the search, man, you're straight. Yeah. So try to jump, I'll open that up, and like I say, go over your notes and stuff, and we'll continue on next class period and look at it. Because we almost finished with the notes, but I want to go over that so that we can we can kind of look at those things. All right.
Sounds good.
All right. So I'll see y'all on next class period, and I'll open up those programs. All right.
All right. You have a good
All right.
one.
All right. You have a good one too.